Welcome back to The Explainer. Imagine just looking up at the night sky, but instead of the gentle, familiar glow of our lunar neighbor, you see a massive, looming sphere growing larger and larger with every passing second. The clock is ticking. You have exactly 1 year until the ultimate cosmic catastrophe. Today, we're strapping in for a high-stakes, scientifically grounded, hypothetical countdown. We are going to visualize exactly what would happen if the moon was crashing into Earth.
Okay, let's dive into this. To really understand the underlying science of Earth and its moon, we've got to map out this grim timeline step by step, day by day. Because by mentally animating this ultimate worst-case scenario, we actually uncover the fascinating physical mechanisms that keep our planet safely habitable right now. So, here's the fast-paced journey we're about to take. We start from the moon's current, incredibly vast distance, which is a gap so wide you could neatly line up every single other planet in our solar system right in between us. But from there, we plunge down to T-minus 300 days, enter total planetary chaos at 100 days, and finally hit zero. That massive gap is closing fast.
At T-minus 365 days, the moon is 384,000 kilometers out. Right now, in reality, it's out there happily orbiting us at a speed of over 1 kilometer per second. Honestly, it would probably love to just fling itself out into the freedom of deep space, but Earth's massive gravity acts like an invisible tether, locking it in. At this exact starting distance in our countdown, you wouldn't notice much panic. If you were standing on the beach, the ocean wave might just splash a tiny bit higher on the sand. But, yeah, that calm is about to completely shatter.
Let's move to Phase 1 and see how this builds. T-minus 300 days, the waters rise.
The distance aggressively drops to 250,000 kilometers. The shifting gravity begins to violently exaggerate the two water bulges around our planet. Basically, the moon pulls the ocean toward it on one side, while inertial forces stretch a second bulge on the exact opposite side. With the moon this close, those bulges translate to massive 5-meter rising tides. Global coastal cities, we're talking New York, Miami, London, are entirely flooded. Evacuations are underway everywhere. Ecologically, it's an absolute nightmare. Coastal animals like sea turtles and pelicans are massively displaced, and aggressive saltwater begins leaching into our delicate freshwater supplies. It's contaminating drinking water for millions.
Actually, let's pause our ticking clock for just a moment to ask a crucial question. Has a lunar collision, or anything even remotely like it, ever had a historical precedent on Earth? To answer that, we have to look all the way back 4.5 billion years into our planet's incredibly violent past.
Enter the giant impact hypothesis, centering on an object named Theia. Theia was this rogue, Mars-sized planet that actually collided with early Earth. Out of the cataclysmic debris disk generated by that massive impact, our moon was born. So the moon didn't just appear out of nowhere, it was violently forged from a massive collision. And here's the crazy part. When it first formed, it was situated much, much closer to Earth than it is today, causing ancient tides that completely dwarfed the ones we see now. And this isn't just some wild guess. As leading lunar researcher Dr. Gordon Osinski points out, the moon and the Earth basically formed out of the exact same starting material. We know this for a fact because of the Apollo missions and meteorites being studied in geology labs right now. When you look at lunar rocks, they are practically identical to Earth's rocks. It's the ultimate proof of our shared, violent origin.
All right, back to the countdown, Phase 2. 200 to 200 days, planetary chaos. The history lesson is over, and the future is looking incredibly bleak. We've dropped to a terrifying 100,000 kilometers away, and we're talking about a staggering number here. Tides aren't just 5 meters anymore. They have now reached 30 meters high. Every city near the water is totally uninhabitable. Essential infrastructure is decimated. Subways, train tracks, coastal roads, major highways, they're all permanently erased under the crushing weight of these super tides.
Now, what's really interesting about this is what's happening right beneath our feet. We tend to just focus on the water, but the moon's rapidly increasing gravity is now heavily straining Earth's solid mantle. This immense gravitational flexing triggers violent global earthquakes. The Pacific Ring of Fire, which holds about 75% of the world's volcanoes and experiences 90% of global earthquakes, completely wakes up. We are talking about simultaneous cataclysmic volcanic eruptions and massive seismic ruptures just tearing the crust apart.
You might be thinking, well, I'll just pack up and move to the mountains. And sure, it's true that high-elevation cities, sitting 1,000 meters or more above sea level, places like Denver, Calgary, and Mexico City, would safely escape the coastal floods. But unfortunately, they wouldn't escape the chaos. They would now be violently battered by those massive, crust-shattering earthquakes. Plus, the changing climate patterns caused by all this atmospheric and oceanic disruption, it would unleash incredibly violent storms and hurricanes right upon these inland havens.
With the end fast approaching, humanity would inevitably look to the sky and ask, is there absolutely any way we could fight back? Could we somehow push the moon off its deadly trajectory before impact?
We do actually have a glimmer of technological hope in our recent history. In 2022, NASA executed the DART mission, intentionally and successfully ramming a spacecraft into the asteroid Dimorphos to alter its course. It proves we absolutely can move celestial bodies. But the moon is vastly larger than an asteroid. Upgrading that technology to push a moon-sized object in less than a year would be near impossible. But here is the massive twist in our explainer today. Human intervention won't actually be necessary, because as the moon closes in, Earth is about to ruthlessly defend itself.
Phase 3. T-0 days. The Roche Limit.
So, the crucial point is, we've reached the climax of our countdown. The moon is now roughly 18,000 kilometers away, totally dominating the sky. But the impact never actually happens. We've hit the Roche limit. At this exact distance, the gravitational pull of the Earth becomes so intensely strong that it actually overcomes the gravitational forces holding the moon together. The tidal forces acting on the near side of the moon are just so much stronger than the forces on the far side that the moon simply cannot physically sustain itself anymore.
If you were to animate this step by step, the physics taking over would be wild. First, the moon violently ruptures, literally disintegrating into billions of pieces ranging from fine dust to asteroid-sized boulders. Second, instead of plummeting straight down like a typical meteor strike, this massive debris field carries its orbital momentum right around the Earth. Finally, over time, this spreads out to form a stunning, shimmering planetary ring system, really similar to the rings of Saturn. Earth essentially just shredded its attacker.
But yeah, don't celebrate just yet. For any survivors left on Earth, the aftermath is pretty grim. That beautiful new ring system casts massive shadows, blocking out huge portions of the sun. Photosynthesis drops drastically, which means the oxygen supply plummets. On top of that, this shadow effect would trigger severe global cooling. And there's precedent for this. About 450 million years ago, scientists believe a similar, temporary ring caused an 8 degrees Celsius drop in global temperatures. Add in constant meteor showers raining down from the chaotic debris, the total destruction of all our communication satellites, and a thick barrier of space rocks that makes leaving the planet completely impossible, Earth basically becomes a cold, dark, and isolated prison.
Phase 4. The reality check.
Okay, everybody, take a massive deep breath. We're cutting away from the disaster to look at the vast difference between hypothetical physics and our comforting reality. And this brilliantly illustrates the contrast. Our doom scenario relies on the moon rushing toward us. The actual scientific reality? The moon is safely drifting outward, away from Earth, at a rate of about 3.8 centimeters per year. This gentle drift means our orbit is beautifully stable. The most drastic effect you and I will ever see from this? In about a century, our 24-hour days will be just 2.3 milliseconds longer. Safe, sound, and wonderfully boring.
But it is incredibly fun to explore the extreme edges of planetary physics through these kinds of visual experiments. So let's end with a thought experiment just for you. If you were forced to dig an underground bunker to survive a cosmic event like the one we just simulated, who are the 5 people you would bring with you to rebuild society? Drop your ultimate survival squad down in the comments, and I'll catch you in the next explainer.